challenging norms in scientific research in an era where scientific research shapes policy, technology, and everyday life. Challenging established norms is not merely an academic exercise, it's a vital act of progress. The history of science is replete with examples of breakthroughs that initially faced skepticism but ultimately transformed society. The traditional paradigms of scientific inquiry are often built upon assumptions that have become entrenched over time. These assumptions can limit the scope of investigation and stifle innovation by discouraging alternative perspectives. Redefining the boundaries of inquiry to challenge norms effectively, researchers must first identify which aspects of their field are considered unassailable truths. This involves critically examining long-held beliefs and questioning whether they remain relevant given new evidence or changing societal values. A prime example of such boundary pushing occurs when scientists question the methodology used in past studies. By revisiting foundational experiments through modern lenses, we uncover biases or limitations that were previously overlooked due to technological constraints or cultural contexts of the time. Critical reflection. When analyzing historical data sets from early 20th century psychology, researchers discovered that many conclusions were based on small sample sizes predominantly composed of male subjects. This realization has led to calls for greater inclusivity in future studies involving human behavior. Re-evaluation of experimental design. Modern neuroscience now incorporates diverse populations across age groups, genders, and ethnic backgrounds to ensure findings are universally applicable. Ethical considerations. As awareness grows around consent procedures and participant rights, contemporary protocols emphasize transparency and informed decision-making processes for those involved in research projects. This shift reflects broader changes within academia towards embracing diversity as both a moral imperative and practical necessity, ensuring that knowledge produced benefits everyone rather than reinforcing existing disparities among different communities. Fostering collaborative innovation through interdisciplinary approaches. The complexity of today's global challenges necessitates approaches that transcend conventional disciplinary boundaries. Integrating insights from various fields allows us to address multifaceted issues like climate change or public health crises more comprehensively than any single discipline could achieve alone. For instance, tackling antibiotic resistance requires collaboration between microbiologists studying bacterial evolution patterns, pharmacists developing novel drug compounds, epidemiologists tracking disease spread trends, and policymakers creating regulations governing medication use worldwide. Interdisciplinary synergy. A recent initiative combining computational modeling techniques from computer science with genetic sequencing methods enabled scientists to predict mutation rates in resistant strains faster than ever before, an advancement critical for timely medical interventions. Such cross-pollination encourages creative problem-solving strategies while also fostering environments conducive to open dialogue among experts who might otherwise operate siloed within their own domains. Embracing open science principles for transparent knowledge sharing. Open access initiatives aim to dismantle barriers preventing equitable dissemination of scholarly work by making research outputs freely available online without paywalls restricting access only to affiliated institutions or wealthy individuals. The movement gained significant traction following high-profile cases revealing how subscription-based journals limited visibility into groundbreaking discoveries made outside prestigious universities, which raised concerns regarding elitism inherent in current publishing systems. Data accessibility. Platforms like arcs4.org allow physicists preprint manuscripts prior to formal peer review. Publication. Similarly, BioArXiv hosts biology-related works under similar conditions promoting rapid exchange ideas amongst professionals globally. This democratization fosters inclusive participation across geographies, enabling talented scholars regardless of financial background contribute meaningfully toward advancing collective understanding across disciplines. Moreover, sharing raw datasets alongside published papers enhances reproducibility standards, ensuring results aren't mere anomalies attributable solely random chance factors, instead solid foundations upon which further investigations build reliably. Dismantling structural barriers within academic institutions. Many universities still adhere rigid hierarchical structures favoring tenured faculty members whose tenure status insulates them against criticism, whereas junior staff face pressure conforming expectations set by senior colleagues, potentially stifling dissenting opinions crucial for true intellectual growth. Power dynamics. In some departments, department chairs wield considerable influence over hiring decisions, impacting diversity metrics negatively, especially when preferences align closely with homogeneous demographic profiles prevalent historically within STEM fields. Promoting equity. Some institutions have implemented blind recruitment practices, removing names and contact information from applications submitted candidates, thus reducing unconscious bias influencing selection outcomes, significantly improving representation among marginalized groups. Additionally, mentorship programs pairing experienced academics willing support emerging voices helps create safe spaces wherein students feel empowered. Voice concerns challenge prevailing doctrines confidently, knowing guidance exists, navigating complex institutional landscapes successfully. These measures collectively help cultivate cultures valuing curiosity above conformity, encouraging continuous learning journeys rather static accumulations, facts traditionally associated with academic rigor. Encouraging public engagement to broaden impact beyond academia. Scientific advancements benefit most when communities actively participate, shaping directions taken during research phases themselves. Engaging local stakeholders ensures solutions developed genuinely reflect needs, priorities identified through direct consultation rather imposed externally. Top-down models. Community co-design. Urban planners collaborating, residents redesigning neighborhoods, incorporating green spaces. Walkability features emerged stronger outcomes compared purely technocratic blueprints, ignoring lived experiences those meant serve. Public outreach efforts. Researchers increasingly leverage social media platforms, Twitter, Instagram, Facebook, disseminating simplified summaries, abstracts, visualizations, helping non-specialist audiences grasp implications. Ongoing studies relate personally. By translating jargon-laden technical language accessible formats, scientists bridge communication gaps, allowing wider audiences engage thoughtfully discussions surrounding contentious topics such genetically modified organisms, renewable energy transitions, etc. Furthermore, interactive workshops, schools, libraries, museums provide hands-on opportunities, explore concepts, practically deepening comprehension levels among participants irrespective educational backgrounds. Maintaining rigor while embracing novel methodologies, while openness, innovation essential driving force propelling scientific frontiers forward. Maintaining rigorous analytical frameworks remains paramount, guaranteeing credibility. Findings withstand scrutiny, subjected repeated testing, verification mechanisms, standard operating procedure within scientific community. Balancing act. New methodologies introduced regularly require validation stages demonstrating reliability, consistency across varied application scenarios before widely adopted mainstream practice. Cross-validation techniques. Statistical tools employed assess robustness, algorithms designed detect potential flaws inherent newly proposed approaches, thereby minimizing risks, errors, propagating subsequent analyses reliant these innovations. Peer review process serves gatekeeping function, evaluating novelty contributions relative existing body literature, determining suitability, inclusion, reputable journals, conferences, presentations. Ultimately successful integration. Fresh perspectives relies careful calibration between adventurous exploration, undiscovered territories, tempered cautionary approach, safeguarding integrity, core principles guiding authentic discovery endeavors. Creating safe spaces for intellectual dissent and debate. Healthy discourse thrives environments wherein diverse viewpoints welcomed, debated constructively rather suppressed, censored due fear repercussions, challenging authority figures holding positions. Power, prestige. Academic freedom. Tenure protections exist precisely enable scholars speak truth, inconvenient even risk backlash stemming ideological differences, clashing orthodoxies dominating particular subfields. Voice amplification. Student-led organizations advocating reform curricula, pushing back outdated pedagogical models, demonstrate grassroots movements capable reshaping institutional policies, gradually shifting tectonic plates beneath surface-level appearances. Stability maintained conventionally. Workshops, roundtables focused facilitating respectful exchanges, differing ideologies foster mutual respect, understanding, dispel misconceptions, perpetuated misinformation campaigns, undermining trust, scientific establishment itself. Sustained commitment, cultivating culture, tolerance, ambiguity, uncertainty, intrinsic nature, quest, knowledge, prevents premature closure, prematurely concluding definitive answers, questions remain unresolved, awaiting further examination, refinement. Supporting underrepresented voices in shaping future directions of research, historically dominant narratives dictated course, scientific inquiry largely reflecting privileged demographics, excluding contributions from minority communities whose lived realities offer invaluable insight, addressing systemic inequities persistently plaguing societies globally. Diversity pipeline. Initiatives aimed increasing enrollment, women, people, color graduate programs, undergraduate levels tackle root causes imbalances, representation, higher echelons, academia, simultaneously expanding pool talent, eligible leadership roles, mentoring opportunities, amplifying marginalized scholarship. Grants funding specifically target proposals originating historically excluded groups, providing resources necessary execute ambitious projects otherwise deemed too risky, venture traditional investors hesitant, assume liability, unfamiliar terrain explored, pioneers. Collaboration networks linking indigenous knowledge holders, Western-trained scientists produce hybrid methodologies synthesizing empirical data, ancestral wisdom yielding holistic understandings, phenomena previously viewed exclusively reductionistic terms. When decision-makers prioritize inclusivity, strategic planning stages ensure myriad vantage points, informing choices, steering trajectories, research investments accordingly, producing equitable beneficial outcomes, all constituents affected directly, indirectly impacted, developments pursued relentlessly. Conclusion: challenging norms in scientific research is a dynamic process requiring courage, creativity, and collaboration. It demands that we continuously interrogate our assumptions, embrace interdisciplinary approaches, and foster environments where diverse voices can thrive. As we move forward, let us commit ourselves to nurturing a scientific community that is not bound by tradition but driven by the relentless pursuit of truth and justice. Only then can we unlock the full potential of discovery to transform lives and shape a better world.